Welcome back to Virtual Bubonicon 2020. Every year we like to put the science in our science fiction by highlighting a local scientist or engineer and giving them a chance to talk about their science. So this year we have an exclusive inside look here at the Space Vehicles Director of the Air Force Research Lab, and we're going to talk to one of their top engineers. So let's head on in. AFRL's clean facilities where we're going to talk to our engineer guest of honor. So let's head over. Hey, thanks for letting us come to your place of work today.
Hey Mandy, I'm glad you can make it.
I don't know what's happening here.
Oh, yeah. 1 second.
Wow, that was a lot of stuff. Can you introduce yourself and maybe explain what all that was about?
Of course. My name is Rachel Delaney, and I work for the Air Force Research Laboratory as a mechanical engineer. And all of that stuff is stuff that we have to wear when we're handling flight hardware. This isn't like a CDC, COVID type of thing. This is because things behave a little differently in space. One of the weirder things that happens is that things can boil at lower temperatures. And what we're really worried about when we handle flight hardware is the oils on our skin. So if we touch anything, we're going to get oil all over it. And when it's in space, that oil is going to end up boiling off of the spacecraft, floating around, and then condensing on the coldest surface that it can find. Usually that's cameras or optics or some sort of sensor. It's kind of like the same thing that happens when you're in a shower and it gets all steamy and you come out and your windows, your mirrors are all fogged up. The difference is, on Earth, you can wipe that stuff off the mirror and use it. But when you're in space, or when you have an asset in space, there's nobody up there to be like, oh, let me wipe this camera, or let me wipe this optic, and let's continue our mission. And so we're trying to prevent anything from getting on the spacecraft that's going to impact our experimental missions.
That's really cool. So you work on spacecraft, as in there are actual spacecraft in space right now that you've touched with your hands.
Well, with my gloved hands, but yes.
That's really cool. I'd like to talk about that more. Can you do that?
Yeah, sure. Let's go someplace that's not quite as noisy.
Rachel, can you tell us more about yourself?
Yeah, sure. So I'm a native New Mexican. I was born and raised in Albuquerque for the most part. I even went to University of New Mexico and got my bachelor's and master's degrees there.
So what got you into this?
So there's a few aspects to that story. So what got me into engineering starts when I was about 7, and I knew that I wanted to be in science. I wasn't really quite sure what I wanted to do in science, but I knew that's where I wanted to be. And I've always had this passion for space, so I realized, oh, I could take this passion for space and this love of science and kind of marry them. That's how I went into mechanical engineering. When it comes to how I got to AFRL, that actually goes back to high school. So the high school that I went to was Hope Christian School, and one of the requirements to graduate was to have a 4-week unpaid internship. And I did my internship at the Air Force Research Laboratory's Education Outreach Program, the AFRL STEM Academy. The following summer, I called them and asked if they had any sort of job opportunities for me because I really enjoyed it. And they told me that that AFRL had actually just put together or just started up an engineering internship program for high school and undergrads. And I was like, sure, sign me up. So I applied, and that kind of started off my whole AFRL career.
Where specifically at AFRL do you work? Obviously, Space Vehicles Directorate.
I work in the Prototypes and Flight Experiments branch at AFRL.
And what does that group do?
Well, that group, our group, designs, builds, and flies one-of-a-kind satellites that push the boundaries of the current Air Force capabilities. Or, as we like to say, exploring the art of the possible.
So you have spacecraft on orbit right now, you said earlier. So how many do you guys have up there?
Well, AFRL has 4. Our group has 3. So we have Eagle and Mycroft, which you can kind of see here. Mycroft was a spacecraft that launched with Eagle. It was actually deployed off of Eagle. We have DSX, and the fourth satellite is from a different organization within AFRL, but that one works in conjunction with the DSX mission as well, and that one is called BPM, or the Very Low Frequency Propagation Mapper.
Acronyms.
Yes,
Yeah.
I like acronyms.
So Eagle, that's the first one you mentioned. Can you tell us about Eagle and whether you did any work on it?
Eagle and Mycroft were both launched in April 2018, and I served as a thermal engineer on Eagle, and I worked launch.
A thermal engineer, I guess like space is cold, right?
Space actually is full of extremes, so it is both cold and hot, and it depends on where the spacecraft is oriented. It's important to, when you launch a spacecraft or have a spacecraft on orbit, that you make sure that it can operate in those temperatures extremes. There are a couple different aspects, like you can have a pretty wide temperature delta on the spacecraft, so you want to make sure that it'll work then. And then you also have temperature cycles. So when you're in the sun, it's going to get pretty hot, but when you go into eclipse, it's going to get pretty cold because it's not getting any heat from anywhere. That change in temperature causes the material on board to expand and contract. And so when you're in low Earth orbit, that expansion and contraction happens every 90 minutes. That can cause a lot of stress on your vehicle. So you need to figure out how to design it so that the temperature changes aren't as drastic, or that it can survive that kind of drastic temperature change.
You also said you worked launch. So is that like you built the rocket?
No, I didn't build the rocket, but there are lots of things that go into launch where you want to make sure that you're not going to damage the launch vehicle during launch. You're not going to damage any other spacecraft that are going with you on a launch. Making sure the spacecraft can survive launch.
Survive launch, like how? What is the concern?
I mean, so space is an extreme environment. You're in your long term, and launch is pretty short, but it can also be pretty hostile. You're on this rocket, there's tons of pounds of thrust, and it's pretty shaky in the launch vehicle, and there's lots of noise. We want to make sure that spacecraft can survive that environment. So we run a bunch of tests and not try to break the vehicle, but see if the vehicle will break. Our goal is to have it survive through those tests, and that way we know it will most likely survive to get to space.
What kind of tests?
There are lots of tests. So the first one that we usually do is the vibe test, because that one's the most intense test, and it's the one that's most likely to break anything. So if you do that early on in your environmental test campaign, you don't have to redo everything if you have to fix something on the spacecraft. But basically what we do is we put the spacecraft on a large speaker, and that speaker essentially shakes the spacecraft and makes it vibrate, and we try and mimic, I think we go a little over what we actually expect to see in launch. If it survives that, it will most likely survive launch.
What about your third satellite? You said that was DSX?
Yes, DSX is the Demonstration and Science Experiment spacecraft, and it's one of my personal favorites because that is the program that I am the deputy program manager of.
Oh, so what does DSX do?
So DSX is an interesting spacecraft because it's in a unique orbit. It's one that we don't normally utilize because it's in the area of the Van Allen radiation belts. So that area of orbit is called medium Earth orbit, usually launched to low Earth orbit, or LEO, or geosynchronous orbit, which is GEO. This one's kind of in the middle of it, and we don't normally go there because there's a lot of radiation that can mess with your spacecraft. It'll start ruining your electronics or start degrading the surface coatings on your spacecraft. And so it's kind of a pain, so we don't normally go there. But we sent DSX there to study that area and study the effects of that radiation on spacecraft and some other scientific missions as well. DSX has 4 experiment suites. The first one is the wave-particle interaction experiment, and in that experiment we are transmitting very low frequency waves through the region and seeing their effect on the energetic particles or the radiation in that area. This is something that we normally see naturally on Earth with lightning. Lightning emits those very low frequency waves, and that can mess with that area. So Problem is, we can't really predict where lightning is going to be or how it's going to affect. So we've put an antenna up there that allows us to control when those very low frequency waves are emitted, and then we can see the reaction in the area.
You're telling me that lightning on the Earth affects space?
Yes, it does.
That's cool.
It's pretty cool. The second experiment is the space weather experiment, and that's basically just to map the energetic particles in the region, so we can get an idea of where things are located and what regions that we need to avoid. The third...
Wait, so before you go on to the third one, you keep mentioning like energetic particles.
Yes.
So what do we mean by that? Like just a bunch of little particles having a party in space?
Well, so they're also referred to as charged particles, ions, stuff that comes off of the sun, because the sun is always belching, I guess, energetic particles into space, and they go everywhere. But Earth is protected by that, or it's protected from that solar wind by our magnetosphere, which captures all of those particles, kind of keeps them in those regions, and keeps us from getting them and having it kill us. You kind of see them with the aurora borealis. That's when they start funneling back down to Earth, but they start interacting with the gases, and it lights them up. They get really excited, but they mostly just reside in that region in space.
This is that radiation that whenever they talk about sending people to Mars and stuff, that could hurt humans, right?
That's right. And it hurts spacecraft too, which is why we don't normally go there. And that's one of the things that DSX is looking at. That kind of leads me into the third experiment suite on DSX, and that's the space effects experiment. So we've put a bunch of components that are typically used on spacecraft on there, and we're measuring their degradation over time. And then the last experiment is called the adaptive control experiment. That's taking advantage of DSX's large antenna booms. These booms stretch 80 meters one way and then 16 meters the other way. So you have this thing that's basically bigger than the launch vehicle that sent it up there in the first place.
The DSX is bigger than a football field?
It's about the size of a football field, yes.
Wow.
So it's really exciting, but it's kind of hard to control because it's big, and yeah, we're not really dealing with gravity the same way that we would like on the ground, but it still creates stresses in those beams when we try to move around the satellite. So if we can better understand that, we can apply that technology to future large orbiting structures. So one of the more exciting things that DSX is doing, we've just been cleared to talk about, and that is that DSX is currently developing a concept of operations for how to clear a potential radiation belt that could be made by a high altitude nuclear explosion.
So you're telling me that if there was a nuclear bomb in space that went off, it would create like a radiation belt?
Yeah, because it will create all of those energetic particles similar to what we see in the Van Allen radiation belts, but it would be at a lower altitude where a lot of our spacecraft reside. And that, as I said, radiation really can impact and degrade your spacecraft. So we would want to clear that out as soon as possible to protect our assets in space.
I was just watching season 3 of Agents of S.H.I.E.L.D., like you do. And if I remember correctly, they did set off a nuclear bomb in space. So you're telling me that the Agents of S.H.I.E.L.D. in that universe accidentally created a radiation belt?
An artificial one, yes. And in that world, a lot of their spacecraft would slowly be dying very painful deaths.
Yeah. No wonder they got rid of Coulson as director of S.H.I.E.L.D. So, all right. You said there were 4 spacecraft. Was there anything you wanted to say about the 4th one?
Yeah, so the 4th one is VPM, and I talked about it a little earlier, but it works in conjunction with DSX. So DSX will transmit different signals, and VPM is in a lower orbit, and it receives those signals, and we can kind of learn how signals get transmitted in that environment. So if you're really into science fiction, which judging by watching Marvel's Agents of S.H.I.E.L.D., I get that feeling, you're going to really like what we're working on next.
What are you working on?
So I'm assuming you've read Isaac Asimov?
The answer to that is, of course, yes. When I was in 6th grade, I was obsessed with Isaac Asimov. But Rachel, if you tell me that AFRL is developing a positronic brain, I will lose my mind.
Not anything quite like that, but do you remember the story Reason?
Sure. That's an iRobot, right? That's the one with the two guys who go out to the mining facility on it's not mining, it's an asteroid, whatever. And that's the one where the robot logics himself into like believing that the equipment they're servicing is God.
Yes, that one. But do you remember why they were on that asteroid space station thingy?
I feel like Rachel is putting me through a trivia test right now, you guys. They were converting power and sending it back to Earth, right?
Yes, exactly.
Exactly what?
That's what we're working on.
You're working on beaming power from space to Earth?
That's correct.
Whoa.
So our latest and greatest project that we're working on is called the Space Solar Power Incremental Demonstrations and Research Project. And the goal of that is to mature technologies to eventually build an operational prototype system that collects solar energy in space, converts it to RF energy, beams that to the ground for it to be reconverted into usable power.
So, spider.
Yes,
if I'm spelling properly here.
Yes, I'm glad that you caught that.
Someone really wanted that acronym to spell spider. So just backing up, why is this something we want to do, right? I mean, we live in New Mexico. We have the sun all the time, and I can just put solar cells out in my yard if I need power.
That's right, but there might be some instances where solar power doesn't work. Can you think of when that might be?
Sure. You can't use your solar cells at night, and if it's raining, then I don't get any power from them.
Right. We kind of solved that problem by putting that solar collection system in space, because we don't have weather. Well, we have weather, but we don't have like rain and clouds or anything in space. And night, depending on what orbit you're in, or what we call eclipse, doesn't last as long as it does on Earth.
So I could get power at night?
Yes, because you could still be in sun up in orbit. So you can see a lot of these technologies that we are maturing in this panel here. So Northrop Grumman Mission Systems is actually developing this panel and pouring in a lot of the technology maturation efforts into this panel. We call it the sandwich tile, where on one side the sun is going to be collected by the solar panels. They're going to be converted into RF on the inside, and then on this side you'll have the RF beaming. We can form it and focus it and beam it to Earth to be received by a rectifying antenna.
A rectifying antenna? What's that?
So a rectifying antenna will collect the energy, and that's how we end up reconverting it back into usable power.
So, I mean, this seems really cool. I can imagine a day where I'm getting power wherever I'm going. My cell phone's always being charged, but I guess I'm wondering, this is the Air Force Research Labs. Why is the Air Force interested in this?
One of the main purposes of the Air Force Research Laboratory is to develop technology to benefit the warfighter. We'll have people out in the field, and the way they get power is very dangerous. They have these convoys that bring power to them. And having a technology that could move that supply line, as we call it, into space could save countless lives, where all these men and women have to worry about is setting up a rectifying antenna and then receiving the power straight from space. And that way, it's like GPS, where you have a solution in space that not just the military is utilizing, but the average everyday person can utilize it as well.
Wow, I mean, this is mind-blowing stuff to me, Rachel. I had no idea that we could get to a point where I could just be getting power continuously from space all the time, day or night. Like GPS, right? You go anywhere and you have GPS on your phone. So that's really cool stuff that you guys are working on here. So thank you so much for taking the time to talk to us here at Bubonicon and kind of give us this hot off the presses information about your different spacecraft and your upcoming spider program. So thank you.
Oh, you're very welcome. It's my pleasure. I love talking about this stuff.
But before we go, I would love to take a moment for us to just talk about some more important topics and maybe get in convention mode.
Sounds good to me.
All right, I love your look here. What are we, best in layout?
That's exactly right, and I really appreciate your Nova Corps uniform.
Thank you. Someone's got to represent the Nova Corps since Marvel sure isn't doing it. And now that we're all spaced up, I did hear a rumor about the Space Force.
Actually, AFRL Space Vehicles is now directly supporting the United States Space Force.
That's very cool. So Space Force right here in Albuquerque, Netflix Live. It's not just Colorado. And now to the more critical questions. Star Wars or Star Trek?
I actually like both. I know I'm dressed like Star Wars right now, but I also have a Star Trek uniform at home too, so I like both.
Kirk versus Picard?
Kirk.
Han Solo versus Luke Skywalker?
Han Solo.
Marvel versus DC?
Marvel.
And then since we are a science fiction fantasy literature convention, we do like our books here at Bubonicon. What is your favorite science fiction fantasy book?
So I don't think I really have a favorite. I love that genre, but I tend to gravitate more towards the dystopian novels. So I really enjoyed the Giver series, and I really liked the Hunger Games as well.
I do love myself the Hunger Games as well. So thank you, Rachel, for being able to join us here today and for hosting us here at AFRL.
Oh, it was my pleasure. I love talking about our research.
And thank you, everyone, for attending. And please attend in person next year at Bubonicon 52, Take 2 in 2021. See you then.